In this lesson, we'll do a brief review of spherical mirrors and image formation. Here's an example of a mirror. That's this black thing here. That's actually reflecting light that's coming from this black arrow here. This black arrow emits a lot of light, and we've drawn 3 of those light rays here. One of the light rays travels parallel here to the principal axis, which is this thing that goes to the center of the mirror. And when that hits the mirror, it actually bounces back through this point here, which is called the focal point. Now that light ray actually continues on for as long as it doesn't run into anything. One of the other light rays that comes from the tip of this arrow actually is one that travels through the focal point first, and then you can see it hits the mirror. That light ray, when it hits the mirror, bounces back parallel to the principal axis. That's, again, this thing here. Notice that this reflected light ray here and this reflected light ray here actually come to a point and they intersect each other at this location. It's at that location where the reflected light rays intersect that we would find an image of the original object itself. Here's another example. It looks very much the same. You can do that using a ray diagram, which is what I've just shown, or you can also do that with a little bit of mathematics. The model for spherical mirrors is 1 over the image distance plus 1 over the object distance plus 1 over the image distance is equal to 1 over the focal length of the mirror. Remember that the focal length of the mirror is the distance from the mirror itself to that focal point, so whatever that distance here would be. In this case, we have an object that's located 30 centimeters away from the mirror. That's from the object here all the way to the mirror. Then we had an image that formed about halfway there. So here's the image located at that spot. Again, the distance to the mirror in this case is only 15 centimeters. And what that would allow us to do is that would allow us to solve for the actual focal length itself. Be careful with your mathematics here. We are adding fractions. 1 over 30 plus 1 over 15 does not equal 1 over 45. Make sure that you use a common denominator if you want to add these together. Maybe 1 over 30 plus 2 over 30, right, which is the same as 1/15, is equal to 1 over the focal length. Since they have a common denominator, 30 and 30, you can add the numerators together. 3 over 30 is equal to 1 over the focal length. And then just remember that when you are asked for the focal length, solve for f, not 1 over f. So if we take the inverse of both sides, we get f equals 30 over 30. And if you actually do the mathematics there, 30 divided by 3 would leave you with 10. If these were originally in centimeters, then our focal length is also in centimeters. Notice that is the correct answer.